In our last section, we learned what a relation was, and we kind of had that idea of a function machine to picture plugging numbers in and getting numbers out. So in this section, we're going to begin to graph different types of functions, specifically ones that look like the ones you see on this page right here. We'll learn in a little bit that these are examples of linear equations, and I know some of you guys may remember how to graph these already, specifically using y equals mx plus b. Whether or not that's the case though, even if you already know how to do these problems, I want you to hear me out and I want you to see how I set this up, because yes, you know the shortcut for graphing lines, some of you, but we're going to learn how to graph new things this year, and the process I'm going to show you right now is always going to work. So it's good to know where the shortcuts come from and learning how to do it the full way before you get into quicker methods. So notice that in these problems here that we're being asked to graph each of these equations. So there are two variables in these equations, and the best way to go about figuring the general sense of what the graph's going to look like is by making a little chart. So we're going to have an input-output table, just like before. So when we're doing our table right here, we can plug in any number we feel like at all for x. You can plug in pretty much whatever you want, and you're going to get an answer. We're allowed to do what we want with x. We call that the independent variable. The independent variable is typically denoted by x. It's the input variable because it's independent. You can do what you want with it and it's fine. The y is called your dependent variable because it depends on what you plug in. Oops, that should say dependent. It's dependent variable because it depends on x. So I can plug in whatever numbers I want for x, and I can see what happens and kind of go from there. So you can plug in 52, 1000, any number you really want, but you have to think for yourself right here, if I plug in a really difficult number, I'm going to get an ugly answer. You want to keep your answers pretty nice. So typically, you're going to want to plug in nice, small integers. Like for example, if I plug in a -1 for x, I pick that number because it seems like it'll give a pretty decent answer. So what I do, I'm plugging in a -1 for x. I want to see when I do that, what do I get for y? So I would have -3 times -1 plus 2. If I toss a -1 in right there, that's going to be +3 plus 2. I'm going to get out a 5. So if you picture that little function machine that we talked about in the previous videos, if I throw a 1 into that machine, it's going to spit out a 5. Sorry, a -1 into the machine, it's going to spit out a 5. So I'm going to plug in a couple more numbers. For example, if I plug a 0 in for x, then I'm going to get -3 times 0 plus 2. That's going to be 0 plus 2. I'll get out a 2, and so on. So I'm going to pick 4 nice small numbers. There's nothing that says you can't plug in pi or a million, but keep it simple. It just is easier to work with. So when I plug in my 4 values right here, I get a nice looking table, like the one that you see right there in blue. And I'm going to come back to how to graph these, but I actually want to get all 3 of my tables done first. So, as always, if you're feeling ambitious, go ahead and try the next ones for yourself, but I'm going to walk through these here. So there's no set number of points that you need to have. I think 4 is a good number for now in these videos, and I'm going to keep the same numbers for x, just to keep it simple here. You can plug in whatever you want, but for our purposes in the video, try to match me just so you can make sure that your answers are right. So on this one, the y isn't by itself, which is kind of weird, but it still works the same way. I plug in a -1 for x, so I get -1 plus y equals -1, and I got to figure out what number that is. Well, -1 plus 0 equals -1. If I plug in a 0 for x, I get 0 plus y equals -1. 0 plus a -1 equals -1, and you just keep doing the same thing. 1 plus -2 equals -1, and if you do it for this last guy as well, it'll be -3. 2 plus -3 equals -1. So there's a table for the second one. And on our third problem, it's the same sort of deal. The f of x right here, remember, that's just another way of expressing your dependent variable. So this guy right here really is treated like a y if it bothers you, that it's f of x. So I'm still going to make my nice little table here. And for this one, when I'm plugging numbers in, there's nothing that says you can't do that -1 like before. If you do that, you get 1/3 times -1 minus 4. Trouble is, if you do that, you're going to get a decimal. That's not bad. It's not wrong. But it's also kind of annoying to have to deal with decimals. In this problem, if you're multiplying by a 1/3, you want to have a number that 3 goes into, because that's going to cancel out your fraction here. So if you plug in these and get decimals, it's 100% correct. You're totally fine. But I'm going to be a little more creative with the numbers I plug in on this one. I'm going to plug in a -3, a 0, a 3, and a 6. Because I see if I multiply those numbers, it's going to kind of kill off my fraction, which is good. And I'll show you what I mean by that right here. 1/3 times -3 minus 4. 1/3 times -3 is -1. And -1 minus 4, I get out a -5. Nice whole number, no decimal or fraction there. 1/3 times 0 minus 4. 1/3 times 0 is just 0 minus 4. I get out a -4. 1/3 times 3 minus 4 is 1 minus 4, which is -3. And finally, if you plug in this guy right here, you are going to get out 2 minus 4 is -2. So I was able to pick clever numbers so I didn't have any decimals or ugly fractions. Again, if you did these numbers, that's fine. It's 100% correct. You'll just have decimals over here for your y. So to wrap up this video here, I want to graph these 3 equations. So I'm going to give myself a little more room here. And all I'm going to do is take my points from the table and put dots at those corresponding places on my graph. So for the first one here, I had -1, 5. So -1, 5, I'll probably have to go by 2's here. Let's see. So that'd be 1, 2, 3, 4, 5. -1, 5. Again, pay attention to my tick marks, not the actual graph behind it. I have 0, 2. So 0, 2 would be right here. I have 1, -1, which would be right here. And I have 2, -4. Now, if you notice on these dots right here, all 4 of those dots line up perfectly. They make a completely straight line right there. If you plug in any other numbers at all, any numbers for x, it might be way off the paper, like way over here or something like that, but they're always going to line up like this. This is a linear equation because the graph makes a line. So I'm actually going to draw in that line. This is an example of a linear graph because the graph makes a line. And we'll get more into linear graphs later on, but basically if it's on the graph right here, like this dot's that right there that I didn't even use, if I were to figure out its coordinates, maybe that's 3, -6 or something like that, -7 I believe it is, that point is on my graph. If I plug in those numbers, it'll work. So I'm going to go ahead and do my last 2 examples here. On my second one, if I take my points, I have -1, 0. This one I'm just going to use my grid here. -1, 0 is right there. 0, -1 is right there. 1, -2. And finally 2, -3. This one is really easy to see that it makes a line. This one was a little sloppier because I used my own tick marks. But if I keep plugging in points, it's going to make another linear graph. And finally, for my last graph here, I'm going to take my points, and with this one again I'll probably have to scale my graph because I don't have a lot of space here. So I have -3, -5, which would be right there. I have 0, -4. I have 3, -3. And finally I have 6, -2. Again, all those points line up. There's my graph.